Hey guys,
Hi,
Hey,
Hello. Ready to get this thermodynamic project done?
let's do it.
so we're going to begin with the paper. The paper the student uses to do his calculations is shipped from the paper mill to the plant of Staples, resulting in a distance of 7.23 miles. The shipment is transported on a 14-feet truck, which has a capacity of 40 gallons of gas and a mileage of 11 miles per gallon. This results in 3.4 times 10 to the 9 joules of work done by the truck. And since maximum work equals G, G equals 3.4 times 10 to the 9. Now, using this, we can find the change of entropy of the universe, which turns out to be negative 1.1 times 10 to the 7 joules per Kelvin. To quantify the vehicle's energy, we used the combustion of octane gas and found the delta S and delta H formation values. The change in entropy is the sum of the entropy of the products minus the sum of the entropy of the reactants. This is the same for enthalpy as well, except with enthalpy sums. Now, using these equations, we found the total change in entropy and enthalpy, which was 9.78 times 10 to the third joules per Kelvin mole and 1.1 times 10 to the 4 kilojoules per Kelvin mole, respectively. To get this paper, the student needs to walk to the Staples store, which is a half a mile away from his house. The average human being walks at a speed of around 3 miles per hour. At this rate, it takes the student 10 minutes to get to the Staples store. This action burns 18 calories of energy, or 75.3 joules. After picking up a pack of loose leaf paper and some pens, the student walks to Fairway Market, which is a half a mile away from Staples, to buy carrots. Since the student walks at the same speed of 3 miles per hour, he uses an additional 75.3 joules of energy. At the market, the student purchases a bag of carrots. Then the student realizes what time it is and decides to run back home because he is so excited to begin his chemistry project. The distance to his house is 0.71 miles, which means that if he runs at a speed of 12 miles per hour, he'll reach home in 2.5 minutes. Of course, this faster travel speed means more energy expenditure. Running back to his house requires 224.5 joules of energy. In total, the student uses about 375 joules of energy.
so Angela, then what is the change of the entropy of the universe?
Alright, so plugging this into the equation for the change in entropy of the universe and considering that the normal human body temperature is 37 degrees Celsius or 310 Kelvin, the total change in entropy of the universe is negative 1.21 joules per Kelvin. So now by the time the student gets back to his house, he is of course tired and decides to have a snack before he starts his chemistry project. So he decides to eat the carrots.
The carrots started as seeds in the ground, which, once planted, were watered and exposed to sunlight, or light energy. This resulted in photosynthesis. For this chemical equation, the change in entropy is the sum of the entropy of the products minus the sum of the entropy of the reactants. This table shows delta S and delta H values for the carbon dioxide, water, glucose, and oxygen. The total change in entropy is negative 262 joules per Kelvin mole, and the total change in enthalpy is 2,802 joules per Kelvin mole. So, at the optimal temperature for photosynthesis, which is 25 degrees Celsius or 298 Kelvin, and using the equation delta G equals delta H minus T delta S, the total calculated value for delta G is 2,880 kilojoules per mole. Therefore, the total change in entropy of the universe for this reaction is negative 9.66 times 10 to the third joules per Kelvin. Once the carrot reaches its maturity level, it needs to be harvested. On industrial farms, such as the ones that supply vegetable companies, large harvesting machines are used. These machines are powered by diesel, and it takes 2.65 gallons of diesel fuel to harvest a single acre. So for a 200-acre farm, this means that 530 gallons of diesel are used. Since there are 1.6 times 10 to the 8 joules in every gallon of diesel fuel, 8.48 times 10 to the 10th joules of energy is used to harvest the field. As before, maximum work is the same as the change in G, so to calculate the total change in entropy, we need to divide by the temperature. The average diesel fuel engine operates at around 200 degrees Fahrenheit or 366 Kelvin. A quick substitution shows that the change in entropy of the universe is negative 2.32 times 10 to the 8 joules per Kelvin. Carrot farms can be found in California and Michigan, but these particular carrots came from Ottawa, Ontario, in Canada. The shipping distance to Fairway Market in Paramus, New Jersey is 408 miles. If, as before, the carrots are transported on a 14-foot truck with a gas mileage of 11 miles per gallon, 1.9 times 10 to the 11th joules of work are done. Therefore, the total change in entropy for this system is negative 6.4 times 10 to the 8 joules per Kelvin. Once the student gets the carrots and starts eating them, he eats about 150 grams of carrots. A serving of carrots is 80 grams, so at 30 calories a serving, he consumes 56.25 calories, or the equivalent of 235 joules of energy. At normal body temperature, 37 degrees Celsius, the change in entropy of the universe for this process is negative 7.51 times 10 to the negative 1 joules per Kelvin.
Now that the student has the necessary supplies to work on his chemistry project, he takes out his calculator to perform the necessary calculations. Using the calculator consists of 3 separate processes: pushing the buttons, thinking, and the calculator power source itself. Each of the buttons on the calculator is about 8 grams and needs to be pushed down 2 millimeters down. Therefore, the work required to push a single button down is 0.16 joules. The work is the same as delta G, so delta G is also 0.16 joules. While thinking, the brain uses 100 watts or 100 joules per second to function. If the student uses the calculator for 30 minutes, assuming that he thinks for 30 minutes as well, his brain does 180 kilojoules of work. The delta G value for this process is also 180 kilojoules. Finally, the calculator is powered by a lithium button cell battery. At 1.5 volts and 150 milliamps, it produces a power of 0.225 watts. If the calculator is used for 30 minutes, 405 joules of energy are used. Each of these processes affect the entropy of the universe. The change in the entropy of the universe produced by pushing a button is negative 5.4 times 10 to the negative 4 joules per Kelvin. The change in the entropy of the universe produced by thinking is negative 604 joules per Kelvin. And the change in the entropy of the universe due to the calculator's power source is negative 1.36 times joules per Kelvin. As a student works on his homework, he does calculations on paper and takes notes. This requires a pen, which he picked up when he got his paper.
Once manufactured, the pen is transported from Milford, Connecticut to the Staples store in Paramus. The distance of 71.4 miles is driven by a 14-foot truck with 40 gallons of gas and 11 miles per gallon. The total work done by the truck is 3.4 times 10 to the 10 joules, which is also the total change in G for this process. Since the truck operates at 25 degrees Celsius, the total change in entropy for the universe is negative 1.1 times 10 to the 8 joules per Kelvin. As the student uses the pen, he uses the energy to push the pen across the paper. Now we are going to add some physics to the mix. The mass of the pen is 2.5 grams, so the force required to lift the pen is 0.0245 newtons. The distance of a horizontal line on paper is about 6.75 inches, and there are 54 such lines that make up the student's work in his notebook. Therefore, the total distance of the lines written by the pen is 9.26 meters. Since work is force times distance, the total work done is 0.2269 joules. This is also the change in G for this process. Assuming a body weight of 150 pounds, the student burns approximately 122 calories per hour for writing and 1.5 calories per minute when thinking hard. If it takes 45 minutes to do the chemistry homework, a total of 665.26 joules of energy is used. At human body temperature, 310 Kelvin, the change in entropy of the universe for the calories burned is negative 2.15 joules per Kelvin. The change in entropy of the universe for the action of writing is negative 7.6 times 10 to the negative 4 joules per Kelvin. So, the total change in entropy of the universe is negative 2.15 joules per Kelvin.
Finally, the student goes to the computer, a 20-inch Apple iMac, to input his answers. Before the student uses the computer, it has been in sleep mode for about 2 hours. Since it uses 1 watt when it is asleep, the iMac uses 7.2 times 10 to the 10 joules of energy, and the change in the entropy of the universe is negative 24.2 joules per Kelvin. The computer then needs to be booted up, a process which requires 105 watts and takes 8 seconds, resulting in a delta G value of 8.4 times 10 to the second joules. The change in the entropy of the universe is therefore negative 2.8 joules per Kelvin. Once the computer is powered up, it requires 117 watts of power. When used for 3 hours, it requires 1.26 times 10 to the 6 joules of energy. The change in the entropy of the universe is 4.24 times 10 to the third joules per Kelvin. And when it's in quiescent sleep mode, which is when the screen goes dark due to inactivity, it requires 56 watts of power. This results in a Gibbs-free energy value of 1.7 times 10 to the 4 joules.
And so, the total change in entropy for this non-spontaneous process of a student working on his chemistry project is negative 9.93 times 10 to the 8 joules per Kelvin.
Sounds good. We're so gonna get an A+ on this.
Hey guys, what are those green numbers and symbols?
I think that's a virus.
Oh,